Okay, welcome to the stream. Today we're going to continue what we were doing yesterday, building this minifier. And what you can see is we are taking this code right here. It's very nice and human readable, and we're going to shrink it into something that's more compact so that it will, when you use it in the library, you see how you have thousands and thousands of lines of code like this. What we want to do is to condense it. We can actually, and now I know that this this works a little bit. You know, it's not doing all of the minification that we want, but it's doing some of it. We're basically stripping out the comments and taking out the new lines. I'm going to open up, where's this? Oh, we can go here. So if I did this correctly, this should just work without me having to do something. So that's actually a good test of it. I'm going to copy, paste into here, and go into here, into this file. This is actually, it looks like a script, but it's actually, it becomes a binary when you run it, when you run with Go. So I'm going to do go run main.go. What that does is when you do this, it actually compiles it and runs it, and then just discards the binary as you use it. Because Go compiles so quickly, it's basically like running a Python script. There we go. That was pretty. I just actually wanted to. You can see the difference between when it's opening and when it's scanning. Okay. So, okay. Opening. Okay. Oh, something went wrong here. Oh wait, no. Maybe it just auto saved it real quick here. Nope. Oh wait, no, the minified, yeah, here we go. Okay, so if we do go run, you can see, wow, yeah. So you can tell that that pause that was there, that's actually it compiling. These happen almost simultaneously because this program's going so quickly. Okay. Here we go. See that we found a problem there, right? All of this, it didn't remove the to-do correctly. Probably because the to-do was inside of a interesting, yeah, okay. Okay. Because the way we're doing it here is, just explain this again, what we did yesterday. So these are just print statements here that are telling us what's happening in the console. We are opening the file, and then we create this scanner from this package. This is like for buffered I/O, input output, and I assume that you're just like, you're creating this kind of iterator that you send the file to. I don't know exactly if this is how it's working under the hood. You know, you send it the file, and then what I'm creating is a builder, and the builder accumulates the strings that you're manipulating. So you iterate from the scanner. So you have this like object, and then you're doing this iteration object, like this iteration operation here, the method, and in each iteration I'm taking the scanner.text, which takes the current line in the iteration, and it gives you a line. Then right here is where I was trying to do the comments, and I was doing has prefix on the line. So if you'd say on the line, if it has this prefix, then it's a to-do, like this little dash dash, right? The problem is, what if the comment is sort of in the middle? It's like, this is assign, let's see, assign IDs. This is in color table. Yeah, so this will actually help if we open up the, just canvas. Oh wait, I wanted to do, I'll open new window. There we go. So we can go back and forth between them. And we do this. We don't really need to look at Audulus today because this is mainly a code-based thing. So do this open and Minifier. Okay. Right. So we're going to go here and go to color and oh, it's already up here. Yeah, see, this comment is actually preceded by whitespace. So the fix for this that I realize now is I need to strip the whitespace first from each line at the beginning of the line, and that will account for these spaces. And you know, basically the whole process of building a minifier is just accounting for all these edge cases and then making like little operations. So we'll know how to fix that. So let's do account for when the comment is not at the beginning string white space. Just writing a comment there for myself for later. So then if you have this prefix, what it was doing is just continue. So it goes around the loop and without doing anything. It's just skipping that line. Otherwise, you are concatenating this line. And actually, I was putting a space here, which works fine. But it will look more condensed if we have a semicolon, which is this guy I met yesterday, Petar, who is on the island. And he's got a really interesting story, but he worked a lot with Lua, and then he reminded me that Lua is each line is actually separated by semicolons, but like modern JavaScript, like a lot of other, like even like Go, you have automatic semicolon insertion. So the way that the program tells the line is done is like this, and you don't put them on return statements. You put them like this, and that's how the program the compiler, sorry, not the program, tells that you're done with that line. Because this way you could, when you're sending, for example, a minified JavaScript file, the semicolon helps, you know, instead of having these spaces in between the lines, you have a semicolon in between them, and that tells, excuse me, when the two lines are separated. And though, well, I guess, I mean, it's monospace, so it'll look the same, but maybe it'll feel more condensed. I mean, basically it's the same thing. Like, if you did this, it's going to do the automatic semicolon insertion, but why not just, like, put the semicolon there in the first place when we're minifying? Okay, and then I'm skipping over this. All these error stuff is just sort of the pattern in Go. It's like when you could possibly error when you're opening a file, say that the script doesn't have, or not the script, the binary doesn't have permission to access the file you're trying to point it at, and then you want to handle that error somehow. And so this return statement actually just quits the program. So here we're writing the string to the builder, and the builder, I assume, is just sort of like an accumulator, and what we're doing is the strings.builder, right? Yeah, the struct, okay. And a builder is used to efficiently build a string size using write methods. It minimizes memory copying. The zero value is ready to use. Do not copy a non-zero builder. Do not copy a non-zero builder. Okay, yeah, that means like don't, like from here, like copy it again, which would make sense. You would want to flush the builder out into a variable, and then if you needed to copy it from the variable and not the builder itself. So we're inserting the strings into the builder, and then if we have an error while the scanner is scanning, then we handle that error here, and we go down to here, and we create a string from the result. We take the method of string from the builder and assign that to this variable result. And that's just for convenience. I can probably rename this something a little better. Let's just rename this. And when I'm doing that, I'm actually renaming it in both the places at the same time. So minified. like minified string. Yep. So at that point it is minified. So, and then we're going to start trying to write to the minified, and we are using the OS package to create a file called minify.lua. I'm going to make, this is all hard-coded right now while I'm doing this, but I'm going to make it so that, you know, when you run this command line utility, you will be able to, you know, specify your source file and destination file names and stuff. But this is just a convenience for right now to not have to work on that logic, to focus on the minification here. And handling the error, and we again return if you can't create the file for some reason. And I forgot to point out this before, there's the same here, file close and out file. This defer keyword defers closing the file that you're opening here to the end of the what's it called, the scope of the function that you're in at the moment. So these files stay open until the main function closes here. And so when it closes, it will actually gracefully close the file too, because you want to be able to. This is the same as like the with open syntax in Python. Then we get a writer, which is, you know, we use this buffered IO and create a new writer, and the writer seems like, what is it going to do? It flushes to writer.write string, minified string. Okay. So yeah, the writer is created from here, and you stick that file in it that you want to write, and you stick the destination file that's here. I've created the file. It's empty. It's just called minified.lua. It's just an empty file waiting to be filled, and then you use the buffered IO to fill the file here, where you go write string, and then you pop this minified string in, and that's why it writes it there. And then if you don't have an error, that's good. You pass over it, and then you are here you go. You're actually you're writing at this point. You're actually just writing it into the buffer of the writer, and then when you do flush, you're actually flushing it to the file. I think. Wait, I gotta ask that actually. I'm pretty new to Go, and so you'll see me asking ChatGPT a lot just to do a quicker Googling, basically. For really simple stuff like this, it works just fine. What is write string versus flush? Yeah. I mean, I could look at the documentation and see just like write string writes a string, returns the number of bytes written. Writes a string. The count is less than length of s. It also returns an error explaining why the write is short. Okay. Writes any buffer data to the underlying writer. Yeah, so like I don't really know exactly what's the difference between these two. Okay. Because like I forgot this before, and it looked like it wasn't. I mean, we can actually just comment this out. Hold on. If you don't use this, hold on. Does it still get written? Yeah, it does, I guess. Okay. Okay. Writes the contents. Okay, so this does do the writing. Yeah, that does do the writing. It's not just adding it to the buffer, it actually is writing it. And wait, hold on. Firefox it loses. Why can't I do this? Well, does the copy work? Of course, I'm losing my ability to highlight there. Can I still write? Okay, fine. Okay. Yeah, Firefox is a little buggy with ChatGPT at least, or maybe it's just ChatGPT. I just don't know why I can't highlight text. flush method writes any buffer data to the buffer IO. The underlying writer, it's necessary to call flush to ensure the data, all data is written to the buffer is actually written out to the file. End of writing operations to guarantee. Ah, this is why. Okay. So it actually was. This is the problem I had before because I think yesterday I didn't put the flush in and I wasn't writing anything. So I think like unless you, I'm seeing it here without the flush because this file that I'm sending it is filling up the buffer that it's saying. So it is actually doing what I was thinking it was doing. This is adding it to a buffer. And as the buffer is overloaded, it dumps it out to the file. This is so that like you're not from the program writing every individual character individually to the file, which is an expensive operation. You're just kind of accumulating the string and then dumping it into the file, and accumulating the string and dumping it into the file. And there's probably some kind of balance between how much you want to keep in memory and how many times you access the file to do that. That's underneath it. So. Okay, and then flush gets like, and actually maybe there even is like, we could see it at the bottom where it's not gonna like flush out the last little bit. We'll delete that and comment this out. No, okay, I guess it does all the way to the, go all the way to the bottom? No, okay. So for that other thing that we were doing before, it didn't, when it was just one file, it wasn't doing it correctly. So, all right, we introduced a problem here where we were going to write line plus this. So why do we have two new lines? We're going to do a switch case here because we're going to have a lot of ifs here. This scan is actually doing, this is the whole program is basically here. I mean, all the meat of it. So we're going to switch and case. I think it's like strings. I think this is how you do it. You don't do if, you do strings has prefix line. Yeah, there we go. Yeah, like that. And then you do continue. Okay. And then the default is this. No, actually, no, because we're going to do manipulation here, and we want to have multiple cases here. But before this, we want to strip out the white space. So, how to strip leading white space from string. Okay. I feel like this, like using ChatGPT like this, isn't cheating. It's just like a real faster Googling, because I would just Google that and see what the method is. It's a strings method, I'm sure. Yeah, trim space. Okay. So okay. Maybe I can just call trim space on. Yeah. Okay. I can just do this again. Assign it to the same variable, right? Yeah, let's just do that. Okay, so strings dot trim space. This is actually not strings are immutable in Go. And so even though I'm reassigning it back to here, it's actually just putting this string that's created here into a different memory address when running it through this line. Wait, what am I doing wrong here? Oh, because you can't, yeah, there. I'm declaring that this line is this, and then I need to reassign it. I keep forgetting that there's a difference between these two. This is like a shortcut syntactic sugar for doing var line like string, right? And then you would do on the next line like this, right? But from what I understand, this is actually, like, you don't want to do this when you don't need to. Like, for some reason, maybe you're declaring it outside of a loop and like, or outside of a conditional, and you want to handle what it is assigned to at the first position rather than trying to like assign it in two places. Because if you do this, it like does two separate operations, versus like doing this all at once. I think like it first goes and creates the address where the name lives, and then it goes and then creates this, and this one does it in the same go, from what I understand. And then we reassign it to the trim the white space at the beginning. So let's see how that works. Wait, hold on. Where am I? What's going on here? I'm just in Go, or in Lua mode. Let me say minified string. There we go. They use camel case in Go, and I'm so used to writing. You can see in Lua, at least I chose the underscore. I think it's a little easier to read. It leads to longer variable names. But okay, let's keep going. Okay. All right. So okay, look at how much more packed that is. Awesome. Okay. Cool. Now why are we creating this double? Oh, because if the line is empty, we also want to skip that. So like, case. I think that's where these double ones, like the line is empty and then it's inserting a semicolin there. True. Yeah, okay, because it's like deleting this empty line, deleting that, or like skipping over this. It's not deleting it, just skipping over it. So these are the two semicolons. That's where they come from, because it's going there and popping a semicolon there and there. Okay, so if in a switch case is just a really nice like way to do a bunch of if statements that's a little more condensed, and I think there's something, the way it's optimized under the hood, that works faster than doing a bunch of if statements. I might be wrong, but okay, case. We're going to do strings dot wait, okay. Like how to check. Well, I think strings dot like this is. Let's see. I'm looking to its methods, the structs methods, and seeing if anything jumps out at me first before just asking. Okay. Like, I think if it's just if line equals this. Let's try that. Yep, there we go. So that removed the leading colons there. I mean, already we have a pretty, like, there's some case that I'm missing that's actually, it's messing up this. Oh no, the syntax, it's just taking a long time to actually render all this. Okay, for some reason the functions aren't coming through a little bit. This is having, it doesn't like that all of this is like this. But let's see, if I save it, it should, if it's correct. Let's give it a little, a smaller, yeah, tokenization. So this is where it's saying I'm not going to like syntax highlight this stuff like if and stuff, which is makes sense because this is one, I guess it's doing it on a per line basis, which is how it does it so quickly. It's just doing the line that you're looking at, but it's not expecting you to be minifying everything, so it's trying to go through and do the whole thing. So if I go all the way down here, it's gonna have to go all the way down here and do the whole thing. So okay, so I'm getting all of this, like I'm getting syntax errors, which is why when I save it, it's not doing anything. If I save it and it's the correct syntax, the what's it called? It's like the formatter should just pop it out and like make it like look like look like this, right? It was similar to this. It won't be exactly like this, but okay. Okay. I mean, is this okay? Trying to think of how to work with this, because this was helping me for a second be able to check if this is valid code, but this isn't liking. If I just scroll slowly, or no, it just stops. Processing incremental semantic tokens. Oh, okay. What do I want to do here? I want to this was helping me. I'm just going to make a smaller test file. I'll just take just details for now. Maybe that'll have an easier time doing this. Okay. So yeah, then we still get the full syntax here. Now, if I press save, okay, this looks good. If we don't have any errors in the file, other than this thing, which is just like it's this duplicate field, I think, because it's seeing it in this test file too. Hold on. Or not the test. Yeah, it's the test file. Let's delete this real quickly, and then I think this should go away, right? Yeah. So it's just not liking that in the test file, it's also seeing that. And this math is missing because it's referencing another thing, but otherwise this is correct syntax. Which is great. Hold on. Why are these getting put there? I guess it doesn't. I think this is the... It's splitting it oddly. I mean, it still works. I don't think I can do anything about that. That's just the formatter. The formatter is being weird. Okay. You know, if the syntax was incorrect, then it would be yelling at me. Even though this looks weird. You know, because this is supposed to be up here. Let's just try replacing it with the space. Maybe it will handle that better. Okay, we'll go back here. And then save it. Yeah, that works a lot better, right? So we can actually, I mean, you know, it doesn't really matter. We don't really have to put this semicolon in there, because if we just put a space, that works fine. And I actually kind of like the look of this a little more. I know it doesn't really matter, but it looks it's a little easier on the eyes without all the semicolons in it. So if I save this, the formatter runs through it and tries to format it correctly, and it works. So that should mean that if we take the full dev library and go up here, this actually, there might be something down here that is confusing it. So let's just go above this. I don't know if that's going to affect it somehow. So add it to the test. We're going to do this. Take this minified version and pop into Audulus, and it's everything above this. Does it still work? Sometimes you have to change something to see if it still works. Oh, it does. Okay, excellent. Wait, let me just save and exit just in case. Reopen it, and it still works. That's great news. That means that the minifier is working correctly, right? So now we can see, you can see where I'm getting to, where this is, wait a second, hold on. Huh, okay. It still works, but it doesn't like the syntax of it gets to this in this print statement in the, yeah, this is in here, the print is the print method, and we're going through and printing, that's this thing right here that you see here, and we're printing each individual element, and the parser for the syntax parser for this thing isn't liking that we have this little token here which says start a comment somehow within a line, and so it's thinking you're starting a comment here, but I guess it's not smart enough to realize that we're not doing that. So we might end up with a situation where the most of the library just looks like this, but that's fine as long as it works. That's what matters. But you can see, okay, see how quickly we're scrolling here. It's still pretty fast, but you can actually tell from the size of the scroll bar right here how much bigger, or more condensed that is. And we can take it even further because, okay, what we're gonna do is this. Right. We're just going so much faster through here. And I guess there is a minimum size for the scroll bar, so it's not yeah. Okay. But when you're in your own code, if you're trying to scroll, you have your code down here and you're trying to scroll around your own code, the amount that you move on the scroll bar is a lot more than here. You can maybe visually see it happening, but this is with the uncondensed code, and every little movement here skips, there's 95, it skips 5 lines. Oops. And it's really tough, and I'm moving as small movements as I can to navigate through my code, which is down here, right? The code that I would have to draw this stuff. But if I do the minified version, this is much easier and much smoother to navigate through that. The next step is you can see we still have a lot of space to regain because we can shorten this to just one variable name. And I wasn't expecting this to go so quickly, but we need to, this is the hard part, right? This was easy. It's a minifier, it works. It condenses everything that you have there to essentially one line, right? It's all in one line, isn't it? Yeah. See, there's line 1. Yeah, that's where line 1 ends, and there's line 2 begins. It's all in one line, but the tough thing is going to be, we're going to have to keep track of variables as we're going through. And that's the actual super big challenge on creating this minifier, is going that extra step. Because right now, this works just as fine. Because we're going to make a list of, yeah. Right here, like, we have a perfect example. Collect garbage. This is a built-in function, so I can't shorten this one. It essentially is a token. But when you create a function, and you get to name it, like here, I could shorten this. I could shorten utils to u, and then, okay, of course it's going to try to complain there. Like this, and then just strip off that, and you probably just do A, right? And you just reassign the name to A, and going through, and you're looking for what do I have available to me to be able to shorten. This is actually the really, really hard part. All of this is really simple string manipulation. You can tell the whole thing fits in a few lines here. But we need to do something more. Okay. So how am I going to go about this? I have to think about this. I feel like one of the first things I need to do is create like a table of all of the Lua tokens, or like a slice of that, so that, or maybe a map. Okay. There was this website I was looking at, like, called Crafting Interpreters, and one of the things that they go over was Elixir, and that's what essentially what we're creating. The inside of the minifier is Elixir, and we have a scanner. Scanner and Elixir are the same thing to some extent, but it's the way you use it in different contexts. But this is scanning through all the lines, and you're want to keep track of the tokens that can't be changed, and then not change those. Right? So maybe for a first pass, we can break this and just, like, let's make sure we can go through and skip over all of the tokens in each line. Yeah. Because, like, we want to split on spaces. So tokens are separated by spaces, right? And then from within some tokens, like this, like a function signature, there's this part that is variable, and this part which you have to do a certain way, and you can only have certain things inside of the these, and you have to know whether or not you can do that. So I'm thinking right now, how do I want to structure the data that is the set of all this, like Lua. Okay. So I go here, and then we go complete syntax of Lua. So these are all of the things we have to keep track of. So like a chunk is like this, like the statement to the last statement, and they're separated by these semicolons. A block is a chunk. I mean, are they the same? What is this saying? Okay. Is it saying like a block is made up of chunks? Like a chunk is a line, and then like a block can like be multiple chunks or one. Okay, no, because a chunk. Okay, that's an optional thing. Okay. Braces indicate repetition, so you can have any number of statements, including none. Okay. Oh, I didn't know that return statements can have semicolons. I guess that makes sense. Yeah. Yeah. Yeah, if you don't return anything, you just do, yeah. Okay. Block is essentially the same as a chunk in this context. A basic unit of program composition. When you write a Lewis script, you're writing a chunk. It could be a file. A block is a sequence of statements that Lewis treats as a single execution unit. Ah, okay. A block is like the scope. So like within a function, you have a block in that function. I see. Okay. Okay. Oh, and then here it's defining last statement. So last statement is return or break, one or the other. That means or. So yeah, this is statements. Okay, this is saying everything that is a legal statement. You know, that would actually be nice. I like writing. You want to put local because it puts all the functions into a table that makes them easier to access and faster. What I don't like doing is when I'm writing this code in the editor, writing local in front of everything, just because it's just expanding the wait a second. I was thinking you can add local there, but is that making that local to, it's local to this context that it's in, right? Hold on. Let's see. I just want to ask, make sure this is local. So, if utils is an object that has a constructor, will making its methods local like this make them private, or is local just local to this file? I think it's just local to this file that it's in. Yeah, to the block. Okay, cool. So yeah, what we want to do in the minifier is actually add local to the beginning of the function if it's not already added. So, okay. Case. Okay, so at every top level function we want to do, put local on it. I know I was sort of, there's so many steps that I'll have to walk through with this. This is going to take me days to figure out, but I'm going to just, if I keep chipping away at these little edge cases, I can build it up like it's supposed to be. So if the case of the function of Okay, case strings.has prefix line function. Then we want to do filter right string I think that will work. Because in this case that it has function at the beginning of the line, we're going to add local, and then we're going to add the line there and there. That should add. Let's go back and just grab that utils file as the test again. And we're going to run this. Okay, we added the local to there. And perfect, that works exactly like we want it to. Oops. Hold on. What's this? Why isn't this formatting? Hold on. No? Why isn't this formatting? It was formatting before, wasn't it? Before I added this. If it's not formatting, then it gives me the impression that something is wrong. But the syntax highlighting looks okay. Yeah, so something went wrong there by adding local. Okay, let's try just unwrap this. So local function for then return true and okay, why can't this? Okay, if I take local off, it does that. But if I put local on there, it doesn't do that. It might be that the what's it called? The formatter is like, it's looking at the local function and says, okay, they want to condense this local function onto one line, and then we're going to skip over trying to format that line. And so let's see this. Okay, I'm gonna do that again. We're going to take out the local. I'm gonna do one local here. Yeah, if I do, let's put a local here, and then it should format everything before it, and not that. Oh no! Wow, you put one local at the top level, and then it's messing up how it's trying to parse it. Okay. So. Okay. I think I want to break out this switch case, like I'm gonna. It would be nice to break out the switch case as a function, but I don't know if I can do that. So, like this switch case is going to get really long. Is there a way to break out just the switch case as a function? I think you could. Yeah, I mean, why not? You can just do, yeah. Okay. Yeah, process line. Okay, so that's what we're going to do. And we're actually going to create another file called like line process. Okay. Let's see. This function is going to be so long. The switch case is going to be so long that I even want to put it in a separate file. So I'm gonna. I actually haven't done that yet. I haven't gotten to that point. Excuse me, in the Go course that I'm working on. So I need to figure out how to do that. I'm going to put this in its own module, its own file, and import it into Minifier. Okay. Okay, like line processor. Okay. Oops. Line processor. Yes. Okay. Yes, that's what you do. Package main, because then I'll have it be able to import strings. Okay. So we're exporting the function from this file to this file, but wait, hold on. Wait, since they're both in the same package but not in the same file, do we still need to export it? Or would that only be if, putting line processor in its own package? I'm pretty sure I know the answer to that, which is that's what I thought. Yeah, to use it across these files. I don't like see. I think we can just think about this like as extending main. I mean, do we really need to add? Like all we'd be doing is like adding like a dot here and then that. Like it's not going to be like this is doing the majority of the work is in this one thing. So we don't need to. Yeah, I don't think we need to do that. So yeah. Process line. String rule. Yeah. So yeah. Line equals strings dot trim space line. I'm just rewriting sort of what we have there before, which is just to, I'm not going to rewrite all of this. Yeah. I actually do this. If I want to put this might actually be, this might is one of the cases where having comments might be nice on each line. But we're going to put this at this line because maybe sometimes these will be multi-line things here. Okay, so okay. Local functions. Okay. Yeah. Okay. Why do we need to return a boolean? What were we doing there? Okay. Actually, I'll be right back. Wait, hold on. First scan, that's scanned. Let's do. Yeah, process down. Skip. Oh, if skip, continue. That's what you're doing there. Yeah, because you need to do it outside the line. So processed. Hold on, I'll be right there back. Yeah, okay. Okay. this line processor to work in here in the scanner.scan. To do line equals scanner.text, scanner.text. And then we're going to do processed line skip equals process line. What? Why isn't this it? Okay, now it's not. Yeah, it just took a second to register that was connected. Or I had an error in that one. It was preventing it from being seen there. Okay. I guess because if you only have one thing, it doesn't want you to. It wants you to import it like that with one line rather than having them in this block. Okay, process line skip, and then skip. Else, we want to do builder dot write string process line plus. Oops. Okay. But how do we get the builder? Okay, we don't have to pass the builder in because we're just getting the line out and then adding it to the builder, yeah. But wait, right? Okay. Oh, okay, I think I was doing something where I was like adding the local to there, but this is okay, just doing it like that, yeah. Okay, what about local functions? Processed line. Wait. Undefined? We're in the same package, so I shouldn't have to export this, but for some reason it's not finding it here. Let's just see if this works. Go. No, okay, so it wasn't that. Wait, AIS, okay, so, why isn't this working? Does this have to do with how? I think these are supposed to be in the same Why isn't this working? I'm puzzled. Puzzled. Then go top right. Is this, do I need to do this thing? Oh, what do I need? Will that work? No. Wait, I can just do go run like that. Go run. Okay, well that worked. I want to go run main. Wait, oh, go run main.go. Oh, because it has to run. I was running just that one file. That's right. If you do this, it looks through the whole thing. That's okay, that's good to know. Okay, cool. All right, does that. That's working now. That's what I was doing. So I was, instead of running all of these files together, I was just running the main.go, and then it got there and I was like, where's this file? Because it hadn't collected it. Okay. So this way we can work just on the line processor in this, okay. What's the next case? What's the next case? You know what? I feel like there's a process line where we're kind of doing stuff at the beginning or end, and then we want to like iterate through the tokens in the line. Yeah, I'm seeing maybe we're creating a map as we're going. So like we look at utils. And yeah, we're creating a map and we're remapping all of these. Yeah. Okay, but let's look for something easier to do that we can keep accruing minification changes in. Or no, maybe this is the time that I have to start adding the tokens. Okay. Now, what structure do I want these to be in? I'm just saying. block with each token token on its own line. Just the token itself, like function do. This. Without the abstract ones like stat. Sometimes explaining what you want is there we go. This is what I wanted. What are the repeats? What is EXP? What does that mean? It's nothing. Oh wait, that doesn't go. Hold on. Let's see. Okay. Like, just... This is annoying. Well, I guess, I mean, the token is the whole thing, right? In some way. Like, it's not just the thing itself. Like, you have to... But, well, in this Minifier project, I'm assuming that the line, the Lua that you're feeding it is good. And we're not worrying about doing syntax checking. That's a whole other thing. Just because it's beyond the scope of this. I mean, maybe I'll add that at some point, but like, what's the point? Because you're writing the code in a code editor ostensibly, and you are checking it, and then as the final thing before you do it, you're giving it to the minifier. So it almost just seems pointless to like program that other than a way to until if then else if then else and for like kind of want to have all these assembly ones down here. Local function, local. I think I did a function. I need to do this in a text file. Use the tokens, just remove duplicate lines. let's do tokens.txt, rename.txt. So we're going to look at this while we're going to create a map of these as strings. And these will be our keywords, or like things that matter in the syntax that we can't mess with. Okay, let's do line processor. Make a new file, tokens.go. Okay, package name, tokens equals make map. Wait, hold on. Map is map, right? Type is, the key is string. Wait, what am I mapping between? I want to be, like, is this true? Yeah. So this is a set. I'm making a set. Yeah. Cool. Right? Because I want to check it against it as if it's a set. Like if it's not in this set of keywords, then yeah. Okay. Tokens set function. True. Is that how you do it? Tokens dot do equals true. Wait, no, we're doing keywords. We're calling these keywords, not tokens. Oh, keywords, symbols. No, actually, because we're gonna start with this as our tokens. Like these are the beginning set, and then we're gonna use this tokens to add things to it as we go along, and then check if they're in there. We actually, this might want to be multi-dimensional, where we have, this is like a set, and then we have another dimension to it where no, we're gonna make a separate map for the remapping of that. Yeah. What here? Oh, hold on. Right? Oh, wait a second, hold on. Import. Expected declaration found tokens. Wait, do I need to... That's what I'm doing. Oh, I was making it like a slice first. There we go. Map string pool. I was in tokens. Maybe it's just complaining because it's in its own line and we're not really doing anything with it yet. We're just kind of, like if, hold on. Can you just, with a string, can you just index into the first symbol? So like, wait, no, it has prefix. This strings that has prefix line, like tokens dot tokens of function continue like that return. Okay, and then undefined tokens. Run like go run non-declaration statement outside function body. 1 second. I'm gonna have to like think about this because maybe this has to like return this as a function somehow to the main. Okay, I'll be right back. Okay, yeah, this is like about like non-declaration statement outside of function body. Okay, because yeah, this is why, because we're making this might have to be its own package. So like yeah, so I think I have to make this its own package. That's weird. Okay. Yes, because you can't, outside of this main loop here, have other functions running. And that's a function right there. And so how do I want to do this? Do I want to make this like a different package? Like, okay, so like we're basically making like the tokenizer, right? And this map is going to help us remap this stuff. Yeah, actually, because I'm going to have two separate maps, the remapping of like this variable is going to be this, and then like because like do I want to get so complex that like when you have a variable inside of a scope in the function, then you could have another variable named the same thing as long as it's in a different scope. And so we're going to have to keep track of scope too. Okay. So let's first get this working though, so that I'm going to make this its own package, which I think you have to do in its own folder. Right. Right. Okay. Okay. Would putting this in another package make sense? Okay, so like has to be in its own folder, right? Okay, so folder tokens tokens.go is in here. Move. Let's package tokens. Then we have to make this, we're going to make this a function. So like our function, like tokens. Oh, we need to make this tokens. Token map, and we're going to do this, and it returns map string bool get token set. Right. Map string bool like this, I think. Okay, see now it's not complaining to me about this. I actually want to do this as like a comma separated list. I want to do, I'm thinking like how kind of like just make this nicer to read rather than having like a wall of tokens that it's creating. And to that we can just add this as like a string and then split on a comma. But the comma is one too, so let's just do this. So, this is another thing that ChatGPT excels at. So like add these to the set. Okay, this looks ugly, but it gets the job done. There we go. So we're creating a set of all the like these are the reserved keywords, like, but we're going to be adding to this as we're going along. Oh, wait, there's also the spread operator. I just recognized that. So then, hold on. Spread. Okay. Why isn't that there? There it is, yeah. I should look at this again. Yeah, it somehow missed out, like, here, the spread. Okay. So it's in package tokens, get token set, exported function should have a comment or be unexported. How do you add docstring to this function? Ah, okay. Sorry. Let's just go with this. Okay, and then if I do in here, like import, so to do tokens. So I'm going to do it here. So like tokens, like map tokens dot get token set, and I think this is what. Yeah. Okay. Good. set. Okay, so maybe we do line processor, and that is processing the beginning and ends, and then for each line, like we have a separate one called token processor. So like token processor. So each name, processor. Then we take in a string, like that's a string. And we output a string. Because we're not doing a bool thing, we're doing a, and then we do tokens. So tokens, token map, which the token set, which equals a map of string bool. Wait, no, I want to be able to do a pointer to this, I think, because I want to, I don't want to return a new map. I want to, okay. This is, okay, and then tokens. I want to, from, within token processor, take in a line and do some things where I'm comparing against tokens. But it seems like I want to take in a pointer to the token processor instead of to the token set instead of the set itself. Because, yes, passing a pointer to the map is a map that can be more efficient, especially for large sets, or the function called frequently, yes. Maps are reference types, meaning they point to data structure in memory. So how do we do this? So, okay, so token set, and do a pointer to that. Why is this in parentheses? Why is token set? Okay. Yeah, processed line. Yeah, processed line. Not parsed line, but we wanted to do like something like that. Token plus like tokens dot token mean, could we just do... Okay. It's still okay, instead of creating new variables, I could just reassign line. I want to make sure that I can just like do this line. Oh, wait, no, because I have, this is why, because I'm trying to assign I would have to do like, yeah, like var skip bool, then line is this, and then like this, just do line, and then line, and then line. All right, I want to see like what it says about this. Okay, acceptable. Okay. Because I was declaring skip and this other variable in the same line, so I have to declare it first. Are you just spitting out what I would? Did I just give you that? Okay. Okay. Get token set. I think I'm going to end a little early here. I can hear the baby, and maybe my wife needs help. Yeah, I'm going to end it early here. I'm going to... I'm just going to save this token processor. It takes in... line. Will this just work? Hold on. And let's get rid of this. Do this. Will this just act like as a skip? I think it will. Yeah. Okay. So we'll leave it there, but essentially we're going to process the line and do kind of line related things, like line level related things on the front and the end, and then we want to go through the line in the individual tokens in the line and process those tokens. Okay. Okay, that's it. And yeah, I'll put this up on the GitHub. Thanks for tuning in for this. I'm gonna keep doing this all this week. This is a part of my doing dev and learning backend development, and so I'm learning Go here, which is why I'm writing this in Go, and I want to do this like as a personal project for this part of the curriculum. So I'm skipped over this a little bit. I'm going to come back to that, but we're going to submit this as my personal project for this one. Yeah. Okay, this will be cool. There's a lot more to work on because we need to, we're going to have these tokens. These are like, or adding tokens to this set. And then, but we need another map that is mapping like the shortened, like we're gonna do like the long version, like utils will be mapped to you, and then it will first go look like, is this a token that I already know? If it's not, okay, I'm going to go to look at this other map and see if it's the shortened thing. If it's the shortened thing, then I can rewrite it here like this. And if it's not already shortened, then let's shorten it. Let's make sure it's not colliding with the other keys that are in that map, and iterating that. So I think if we just take this step by step, it will work out okay. All right, cool. Thanks. I will catch you on the next stream. Peace.